So in data structure, there are two terms. One is data, another one is structure. Can anyone tell me what is data? Dear students, can you tell me what is data?
Sir, anything that we stores in our system.
Okay, very good. Next, anyone else? So data means what? Raw facts that can be stored and processed. It's known as data. Right? For example, if I will tell you that Ramesh is a data for you or Ashish is a data for you, 5 is a data for you. So these are data, right? So raw facts that can be stored and processed is known as data. Now what is data structure? Can you tell me what is data structure? Dear students, I want answers from your side. What is data structure?
Sir, sir, to arrange the data in a proper way, known as data structure.
Okay, arrange the data in a proper way. Okay, why you will arrange the data in proper way?
Sir, if there is so many of data, and then they will be mixed up, and uh, it will take more time to find the data. So that it will, if we arrange the data in a proper way, so it will be easier to find us.
Very good, very good, very good. Absolutely correct. So now data structure, it provides a way, data structure provides a way to store and organize data in order to facilitate easy access and modification. This is known as data structure. So data structure provides you a way to store and organize data. So why you will store and organize data? In order to facilitate easy access and modification, right? So this is all about your data structure. Now you see in data structure which books you have to follow. So the first book is data structure by Mark Ellen Weiss. This is one book that you can follow. Then another one is Data Structure by Tenenbaum, right? Or you can follow the NPTEL site where you will get some video lectures and web lectures on data structure, right? So these three resources you can follow to learn data structure, right? And I will also send you some links where you can study data structure, right? So all of you know what is data structure. Now we will do the classification of data structure, right? Classification of data structure. So the data structure is broadly classified into two categories, right? One is primitive, another one is non-primitive. So under primitive, what you will get? We will get your characters, integers, float, double. These are your primitive data structures, which are directly provided by your programming languages, right? Now, can you tell me how characters are stored. So you see, data structure provides a way to store and organize the data. So in computer, how characters are stored? Dear students, characters are stored by their ASCII values, right? So in C, characters are stored by their ASCII values. So every character is associated with an ASCII value. So when we want to store the character, actually that ASCII value is converted into binary equivalent. Then that binary equivalent is stored in your memory, right? Similarly, for integers, the integers are converted into binary, then it is stored. Signed and unsigned integers, signed and unsigned binary equivalent, then it is stored inside the computer. This one you know. Now can you tell me how floating point numbers are stored? Floating and double numbers are stored. The float and double numbers are stored by using IEEE 754 floating point standard, right? So if you go through the web, you can easily find how floating point numbers are stored. IEEE 754 single precision format. For float, you will use single precision format, and for double, you will use double precision format. So you see here, I request all of you to go through the floating point representation format. Okay. So you see the float occupies how many bytes? 32 bytes, 32 bits or 4 bytes, right? So out of which 1 bit is considered as sign bit, 8 bits are used to represent the exponent, and 23 bits are used to represent the mantissa. So this is IEEE 754 single precision floating point standard, right? Means for float data type, the values are stored like this. Similarly, this is IEEE 754 double precision floating point numbers, where 1 bit is used for sign bit, 11 bits are used for representing the exponent, and 52 bits are used for representing the mantissa, right? So I want all of you to go through this one, how floating point numbers are stored in the computer, right? These things you should have studied in programming in C. Next, we will go through non-primitive data structures. So the non-primitive data structures are broadly classified into two categories. One is linear data structure. Another one is nonlinear data structure. So under linear data structure, we will have two data structures. One is stack, another one is queue. Similarly, under nonlinear data structure, we have two different types of data structure. One is tree, another one is graph. So let me distinguish between the linear data structure and nonlinear data structure. So in linear data structure, In linear data structure, the data elements are stored. The data elements are stored in a linear fashion. Linear, that is, each data element is associated with a maximum of two adjacent data elements. Right? For example, your stack and queue. So you see in queue what happens, the insertion are done through one end and the deletion are done through another end. The insertion are done through rear end and the deletion are done through front end, right? So now you see here each data element 15 is associated with two of its adjacent data elements. One is 2, another one is 16. Next 10 10 is associated with only one data element, that is 20. So that's why here I have written is associated with a maximum of two adjacent data elements. So for the first and last element, it is associated with one element. For the remaining element, it is associated with two of the adjacent data elements. All of you are clear regarding linear data structure, dear students? I want your answer, yes or no?
Yes, sir.
Yes, sir.
Okay. Now we will go through nonlinear data structure. Nonlinear data structure. So in nonlinear data structure, in nonlinear data structure, the elements are organized in a hierarchical manner. That is, each data element may be associated with any number of other data elements. For example, your tree. Okay. So example of nonlinear data structure are tree and graph. So your tree. So suppose you are having your directory structure. So here you are having my computer. So you see my computer, under my computer you will have many drives, right? C, D, E. Then C drive, under C drive you may have many folders, right? For example, your desktop, next your
The program files.
program files, next your other directories, right? Similarly, under D you may have many folders, under E you may have many directories, right? So here you see, here each data element is associated with any number of other data elements. There is no restriction, right? So this is your example of your nonlinear data structure. So I hope all of you have understood what is linear data structure and what is nonlinear data structure. So throughout this data structure course, we will not cover anything else apart from this stack, queue, tree and graph, right? So next one is yours. So this is all about your data structure. Next, we will go through algorithm. Can anybody tell me what is an algorithm? What is an algorithm? Yes, you know it. Don't worry, if it is wrong also, no problem. You please tell what you know. What is an
Sir,
algorithm?
sir, they are the sequence of steps to solve a particular problem.
Very good. Sequence of steps to solve a particular problem. Any other student? What is an algorithm?
Set of instructions to perform a task.
Okay. Let me tell you what is an algorithm. So it is any. So here the important term is any. So an algorithm is any well-defined. So it should be well-defined, right? Computational procedure that takes one or more value as input and produces an output. So you see here why I have written, why I have underlined in. So for example, if I will ask you to sort a list of elements, then what you will do, sir? There are so many algorithms. One is bubble sort, one is insertion sort, one is quick sort, one is merge sort, right? Okay, any problem, dear student? All of you, please mute your microphone. All of you, please mute your microphone. Okay. So now you see it is any well defined. So any means what? Let me explain you. So if our task or if our problem is sorting. So in order to sort the data, either you may use bubble sort or you may use merge sort or you may use quick sort or you may use other sorting techniques also, right? So you see there is a single problem, that is sorting. So you see, in order to sort it, you may either use bubble sort algorithm or merge sort algorithm or quick sort algorithm. So it means what? What is an algorithm? It is any. So out of many, it can be any one, right? So it is any well defined. So you see, bubble sort has a well defined set of steps. Similarly, merge sort has a well defined set of steps. Similarly, quick sort is also having a well-defined set of steps, right? So what is an algorithm? It is any well-defined computational procedure that takes one or more value as input and produces an output, right? So here the important terms are, there are two important terms. One is any and the second one is well-defined, right? So if I will ask you to prepare a tea, so you see, this is also a problem. So in order to solve this problem, what you will do? You will follow a set of procedures. So first you have to take a pot, then you have to add milk to it, then you have to put it on a gas, then you have to switch on the heater or gas, right? Next you have to add some sugar. Next you have to add the tea leaves. Next you have to stir it for 5 minutes. Then after that you have to filter it. Then you can take the tea. Your tea is prepared. Now you see, it is a well-defined set of steps, right? Suppose what you will do, you will take a pot, you will add milk to it, sugar to it, and tea leaves to it. You have to stir it up for 5 minutes. Then after that, you have switched on the gas. So you see, your tea will not be prepared, right? So algorithm means what? It is a well-defined computational procedure. These steps are should be well-defined, right? Next, so it is any well defined. So you see, in order to sorting, here I have told you three sorting algorithms, right? So which sorting algorithm you have to use? So for that you need to analyze the algorithm, right? That is called as analyzing an algorithm. What do you mean by analyzing an algorithm? Analyzing an algorithm means predicting the resources needed by the algorithm. So what might be the resource? So resource can be what? Resource can be what? It may be time. How much time it requires. It may be space. It may be bandwidth. If you are using an internet application, how much bandwidth it consumes. That also it depends, right? So here, if we measure the time, then we will call it as time complexity. If we will measure the space, that we will call it as space complexity, right? Now let me go through the time complexity of an algorithm. Time complexity of an algorithm. Can anyone tell me what do you mean by time complexity of an algorithm? Dear students, What do you mean by time complexity of an algorithm? You have already used it. Big O of n log n, big O of n square, big O of n. Okay. So what is it? What do you mean by time complexity of an algorithm?
Sir, it
Sir, how
means
much time I
how
could
much time it
require to process and
required to.
execute the program?
Okay. So you are telling
Maximum
that
number of times the program.
maximum number of time. Okay. Any other student?
The maximum or the minimum, both, sir.
Okay, maximum or the minimum means you are telling the time required to execute a program or execute the
Yes.
algorithm. So now you see, I will give you a simple scenario. Okay, suppose what you have done, I have written a program. Okay, you want to measure the time. So I have written a program, then you run it on a i3 processor. Okay, same program, you run it on a i3 processor and measure the time. Suppose it takes 10 seconds, right? Now, if I will take the same program and run it in a i7 processor system, it will take less amount of time or more amount of time?
Less amount.
Less amount of time. So you see, same algorithm, but you have just changed the computer so that it takes more time or it takes less time. Yes or no? So if you will measure the time of an algorithm, time required by an algorithm, it is a dependent thing. That is, it depends on the underlying architecture. It depends on the underlying machine architecture. What else it also depends? It depends on the compiler. So you see, if you will write a program, if you are using a outdated compiler, now you have written the same program, but you have compiled it by using a modern programmer where optimizations are done more efficiently, then the person who is using the modern compiler, its time complexity will be less, or the amount of time required by that computer will be less, right? So it also depends on the compiler. It also depends on the underlying machine architecture, and it also depends on the programmer, right? So you see, in order to swap the two numbers in the bubble sort algorithm, what we have written, we are swapping the values, right? So in order to swap, what algorithm may a programmer use? It will use temp equal to a equal to b, and b equal to temp. One programmer is using this one. Another one is using what? A equal to a plus b, a equal to a minus b, and b equal to a minus b. Now you see, both the things will swap the variables, right? Or both the things will swap the values. But which one is better? First one or second one? Which one is better?
First one.
First one is better. Because here you see, here you are just using the transfer operations, means copy operations, where you are doing the complicated addition and subtraction operation, right? So if a programmer, same algorithm, you see same algorithm, but a programmer chooses to use the first approach for swapping and another one chooses to use the second one for swapping. So the amount of time required will change, right? So usually time complexity doesn't measure the amount of time. Rather, what it measures, time complexity of an algorithm means or measures the number of primitive operations used in the algorithm, right? So time complexity measures the number of primitive operations used in the algorithm, right? So the time complexity can be measured in three ways. Okay, one is best case time complexity, best case time complexity. Second one is average case time complexity, and third one is worst case time complexity. Right? So first one is best case time complexity. Best case time complexity. So what is best case time complexity? It is the minimum number of steps that is required by the algorithm to solve a particular problem. Right? To solve a particular problem. So for example, if I am using insertion sort. What is the best case time complexity? In insertion sort, what we will do? We select a key element. We are given with a set of elements. Our job is to sort the elements. Then what we will do? We select an element as the key element from the 1th index. Then we will compare it with the previous element. If the key element is smaller than the previous element will be swapped or will be moved forward by one index, right? Similarly, the key element will be the next element, then it will be compared with this one, it may swap with this one, or it may be shifted with this one. Next, the key element will be this one, next, the key element will be this one. So, if the array is already sorted, it requires how much time? It requires n operations, right? So, the time complexity we are representing as big O of n. So what is big O? So big O is a function defined over the input instance n, which represents the maximum or which represents the upper bound of an algorithm, right? Upper bound means beyond that it will not take more time, right? So in insertion sort, the best case is big O of n. What is the worst case? In worst case, if the array is sorted in reverse order. So like if the array is sorted in reverse order, for example, if it is like this 12, 9, 7, 5, 2. So you see for this one, it will shift the element by one position when 9 is the key. So now it will become 9, now it will become 12. Now when 7 will be the key, the 12 will be shifted to here and 9 will be shifted to here. So for the first one it requires one operation. For the second element as the key element it requires two operations. For the third element it requires three shift operations. Then similarly for the nth element it requires this operation. So what is the worst case time complexity? It's nothing but n into n plus 1 by 4. This many a number of primitive operations are required. So the worst case time complexity for insertion sort is nothing but big O of n square. So what is big O notation? So there are three notations. One is big O notation, one is big omega notation, another one is theta notation. This you will study elaborately in the algorithm subject, right? But let me introduce you these things roughly, right? So big O notation gives you what? It gives you asymptotic upper bound. This will give you asymptotic lower bound, right? And theta notation will give you both upper and lower bound, right? So now usually the big O notation is used to compare the algorithms because it provides the upper bound of an algorithm. Means beyond this it will not require more number of steps, right? So in the worst case it requires this many number of steps, right? So usually the big O notation is used to represent the time complexity or to compare the algorithms. You can use any notation to represent the time complexity of an algorithm, but usually big O notation is used to compare that. If you want to know out of these sorting algorithms, which one is the best sorting algorithm, so we will use the worst case time complexity, that is, or we will use the upper bound. So here it is big O of n square. For merge sort, it is big O of n log n, and for quick sort, it is big O of n square. Now, which function has the lower growth? Big O of n log n, right? So we will prepare merge sort while sorting an algorithm, right? So now I will tell you what is n square, what is n log n, what is n square. Okay. So now you see, suppose here I have taken one algorithm, big O of n, where n is the what? Number of inputs, right? Or in a sorting algorithm, if there are n elements, then n represents this one, right? The number of elements. Now let me take another one, big O of n log n, and another one, let me take it as big O of n square. Now you see, if n equal to 1, then it requires how much number of operations? One operation. This requires what? 1 log 0 means one operation. It requires 1 square, one operation. Now n equal to 2, it requires how many operations? Two operations. It requires 2 into log 2 base 2 means it requires two operations. Big O of n square, it requires 4 operations, right? Now n equal to 3, so it requires 3 operations. It requires 3 point something, because 3 log n log 3. 3 log 3 means 3 point something. Let's say 1 8. Let us say, okay, I don't know, but it should be like this. Next, big O of n square, 3 square is 9. It requires 9 operations, right? Next, n equal to 4. So it requires 4 operations, whereas it requires 4 into log 4 means 8 operations it requires. Big O of n square requires 16 operations, right? So you see, nowadays the number of or the size of data is huge. So if the algorithm takes this much amount of time, big O of n, you see the order of growth is pretty low. So here you see, if I will take n over here, and if I will take the order of growth over here, then how it grows? So for this one, for n equal to 1 or big O of n, this is the order of growth, big O of n. Now for this one, big O of n log n. So 1 means 1, 1 means 1, 2 means 2, so 2 means 2, then 3 means it requires some more steps, right? So 3 means it requires 3 point something. Next 4 means it requires 8, so it requires, so when it is 4, then it requires 8 steps like this. So you see the order of growth of n log n is more than big O of n, right? Now, if I will go for n square, so n equal to 1, it is 1, n equal to 2, it is 4, n equal to 3, it is 9, n equal to 4, it is 16. So you see the order of growth of big O of n square is more than n log n, which is more than big O of n, right? So now, if I will ask you whether you will choose big O of n square or you will choose big O of n log n, which one you will choose? Dear students, you see big O of n square, the order of growth is more than big O of n log n. Means the number of steps, primitive operations required will be more by bubble sort than by merge sort, right? So you will select the lower number of operations, the algorithm which consumes or which has lower number of operations, we will select that one so that the time complexity will be less. Yes, so we will choose merge sort. So all of you are having a bit of knowledge relating to these terminologies. Yes, students, yes or no? I want your answer. Is there any doubt? Okay, Prasanjit, you tell me. Prasanjit Behera. Prasanjit, where are? Prasanjit. Okay, is there any other doubt? Dear students.
Okay.
Okay. So now we have gone through what is data structure, what is algorithm. So when you are solving a problem, two things are required. So two things are required. So data structure. So you have to choose an appropriate data structure, plus you have to choose an appropriate algorithm. So data structure plus algorithm gives you the solution to a problem, right? So if I will ask you, I will give you a problem, then the poor or weak programmers concentrates on code, while good programmers concentrates on a good programmer concentrate on data structure, means which data structure to use and which algorithm to use, right? So first you have to choose which data structure I will use to represent the data or to store the data and organize the data. Second one, you need to consider which algorithm I will apply so that I can efficiently solve that problem, right? So whenever I will give you a problem, then what you have to see, you have to see which data structure I will choose to store it and organize the data. And second one is which algorithm I should apply so that I can efficiently solve the problem, right? So next is, we have gone through array, right? We have gone through array. Now today we will go through address calculation of array. Address calculation of array. Okay. So now can you tell me what is an array, dear students? What is an array? I have already told you these things. What is an array? Dear students,
Sir, it is a pointer to the starting memory address location.
it is a pointer to the starting memory location. So it comes under your first module. Okay, whatever I am covering right now, these all things comes under your first module. Okay, what is an array? Somebody else?
Collection of a similar type of elements.
Very good. So you see here
Storage
just
contiguously.
stored contiguously. And third one is represented by a common name. Okay. So what is an array? An array is a collection of similar types stored contiguously represented by a common name. So if I will write integer a of 5. So you see address calculation for one dimensional array I will go through first. Then I will go through address calculation of two dimensional array. Okay. So integer a of 5. So you see here we have taken an array which contains 5 elements. So its first element is a of 0, second element is a of 1, third element is a of 2, fourth a of 3, a of 4. Now these are stored contiguously. Suppose the starting address is 1000, then the next address should be 1004. Next address should be 1008, 1012, 1016. Now if the base address is given, let's say the base address means the starting address equal to 1000. Then array type What is the type of the array? It is integer type. Let's say integer means each element occupies 4 bytes. Right. Now, what is the address of? If I will ask you a question, what is the address of a of I? Then what you will write? It is nothing but
1000.
base address a of I, not 1. Okay, it is a of I. It is base address plus I into size of the type. Right. So this is the formula. Address of a of I equal to base address plus I into size of the type. So now you see, for example, if I want to compute address of a of 2. So base address is what? 1000 plus I is what? 2 into, what is the size of the type? What is the size of integer? 4 bytes. Size of each element is 4 bytes. So how much I will get? 1008. So now you see a of 2's address is what? 1008. So this is the address calculation formula for one-dimensional array. Now let me go through a two-dimensional array, right? So two-dimensional array. So two-dimensional array consists of some rows and some columns. Let the rows are represented by R and the columns are represented by C. Suppose I have taken an array A of 3, 3. Okay. So the first element is A of 0, 0. Second element is A of 0, 1. Third element is A of 0, 2. Right? Similarly, 1, 0, 1, 0, 1, 1, 1, 2. Similarly, 2, 0, 2, 1, 2, 2. A of, right? So now you see, if the static address is, if the base address is, so how it is stored in the memory? It is stored in the memory like this. Okay. It is also stored contiguously. 4, 5, 6, 7, 8, 9. Right? So let's say the starting address is 1000. So this one is A of 0, 0. This one is 0, 1. A of 0, 1, right? A of 0, 1. A of 0, 2. A of 0, 3. 0, comma 3. Right? Next, A of not 0, 3, it should be A of 1, 0. Right? Next, A of 1, 1. A of 1, 2. Next, A of 2, 0. A of 2, 1. A of 2, 2. Right? So its starting address is 1000, then it should be 1004 if it is an integer type of array. Next would be 1008. Next would be 1012. Next would be 1016. Next would be 1020, 1024, 1028, 1032. Right? So how you will compute the address of ij? So address of A of ij is nothing but base address plus I into number of columns, right? Number of columns into size of each element plus j into size of each element. So now you see, let me compute the address of A of, let's say 1, 2. So what you will get here, I is 1, j is 2. So what is the base address? Base address is 1000 plus I into c into, here c is what? It is a 3 cross 3 matrix, right? So I into C into size. What is I? I is 1. C is how much? C number of columns is 3 into size. What is the size of each type? It is 4 bytes. Plus J into size. What is the value of J? J equal to 2. So 2. What is the size? 4. So now you see what you will get 1000 plus 3 into 4 12 plus 2 into 4 8. So you will get 1020. So now you see here we are computing the address of A of 1 2. So you see A of 1 2. What is the address? It is 1020. So this is the address. This is the formula to compute the address in case of a 2-dimensional.